Hello, hello. Welcome to the first of what I hope is many live streams sort of going over the CAD. My name is Brad Pearson. I'm the program director at Baker College for our engineering and applied technology programs. And what I thought I'd do with this live stream, my first one ever, if that doesn't show by the, sort of haphazard setup and late notice out to everyone and all that good stuff. As I thought that maybe someone might find it useful if I sort of walked through my thought process while going through a mechanical design. So last spring, our mechatronics students did a capstone project, and they called it the Stinger robot. And the idea was it would give us a sort of programming platform for use in various programming courses, both on the information technology side of the world and on the engineering side of the world, with dual purpose that, the initial prototypes, the initial product of that project, there were 5 total students, they gave me 5 robots, would act as sort of outreach robots. So when we go to career fairs or middle schools, when I go to give talks and sort of talk about engineering and talk about our programs, I'd have something to demonstrate that, our students actually output, right? Prove sort of what it is we do here. So the ultimate result was this guy. They call it the Stinger robot. The original design was sort of based on the Ozobot, little golf ball sized guy. And the students decided to build a robot that not only could we say, we use in classes, but that we build. So this thing has been a massive hit at those outreach events. Kids and students and everyone that comes by the booths and whatnot love it. And it is absolutely awesome. They did a great job on the project. The sort of, I don't want to say problem with it, because it's not really a problem with the robot itself. It was really a problem with the advice that I gave them while they were designing and building the thing. I sort of underestimated just how violent visitors to those events can be towards the equipment that we bring. So this is sort of the, this is the sort of Paragon, the pristine one. This one, because it's the only one that we actually have with a display. When they built these, Arduino was actually out of stock, so we only had one display. They're all capable of accepting the display. But this one has spent all of its time basically in my hand, demonstrating the touchscreen. The ones that we actually let the visitors to the booth drive around all sort of nowadays look like this. Notice the broken ultrasonic motor or ultrasonic sensor mount. The Arduino up here is hanging on by a thread. All the mounts are broken. We have wires unplugged. There's a solder joint down below on the power switch that came undone. Now, the benefit to that is it actually broke to the point where I can't turn it off. So, if something's going to break in the middle of a career fair type thing, that's sort of the way you want it to break. So to turn this guy off, I actually have to unplug the battery here on the power board. So again, I don't want anything here to sound like these students did anything wrong. These robots are excellent. Like I said, the visitors to our booths and whatnot that see these and get to play with them, they love it. We just need to be a little more tanky to survive sort of that environment. So over the summer, another student worked on a sort of version 1.5 of the robot, and this is, his prototype for version 1.5. This one still had some issues that we're working through. So the motors, as you can tell, are sort of missing with the wheels. They would go here on the sides. They are no longer attached because, again, violence at these sort of outreach events. So this guy is sort of based around the idea of maximum robustness, maximum survivability, so that it can survive in those kinds of environments. To that end, where the original design is wired from all the sensors directly to the Arduino's input ports, I set out and basically designed a custom PCB that gets rid of the bulk of the wiring anyway. The battery's still wired, and the motors will need to be wired, but just about everything else attaches to that PCB, and everything just sort of plugs in. So the new version 1.5 is sort of based around that. So what I thought I would do, and again, I thought maybe someone might find it helpful. I've got quite a bit of experience in, the mechanical design aspect of these things, along with other parts and industrial components, all that good stuff. I thought someone might find it useful if I sort of went about redesigning this chassis and sort of did it live and talked through the thought process of sort of building up something like this. And I thought, given that, I'm primarily a SolidWorks guy, I thought I would do this with Onshape, which is the title of the video, or the title of the stream. I am definitely not an Onshape guy. There's a video on this channel I did that was sort of a first look to kind of see how it compares to SolidWorks, which I'm used to. And I mean, it is very similar. And in the meantime, I did take a stab at sort of redesigning this. And the thing that ultimately gave me the idea for this video is, as I was working through and sort of modifying this chassis a little bit and adding some more features and really polishing it up, I sort of didn't like the route my design of this was taking. Basically, I was coming at it from the approach where it would be machined, and that's really not the case here. I mean, these things are going to be 3D printed. That was always the intent. That way, I mean, it's a fairly cheap robot. By 3D printing them, we can actually have students, even remote students, that have 3D printers, print their own and just add the purchase components to it, and have a functional robot that they can use in online classes or for self-directed learning and that sort of thing. So 3D printing is really the goal. And as I was working through, I literally deleted the entire Onshape project that I was working on, because I realized that the approach that I was taking, where everything is sort of top down and able to be machined, wasn't the way to go. So I decided that we could get away with getting a little nuts, and to do that and sort of not influence myself starting from scratch, I sort of decided to delete that whole thing and just start from zero. So I'm going to go ahead and switch views here. I've got Onshape open, and the only thing I've got left in it is the Arduino itself. The Gig R1 Wi-Fi is the only thing here left. I actually deleted the whole project down here at the bottom that had my original design. So where I would start, also I should just note that, anytime I sit down with SolidWorks, Onshape, any kind of CAD, any design really, I should note I've always got in front of me, so if you see me looking down at my desk and scribbling furiously, I've always got an old school calculator and a pad, just a pad of paper, because I'm pretty terrible at memory. So as I'm switching back and forth between parts and taking measurements and whatnot, I'm usually scribbling down the measurement that I need to input in the other tab. So the place I would start, well, first I need to create a document for this thing, and we're going to call it Stinger 1.5. And 1.5 is on purpose because, obviously this guy is, the Stinger. And Stinger 1.5, because electrically, this PCB on the new design is designed to be electrically identical to all of the wiring and the hookups that the original team designed into the first Stinger. So that's why 1.5. Now I do have in my head in the future, students may or may not know this yet, if any of them happen to tune in. I see one tuned into the stream, but they may or may not know that version 2 is forthcoming as a project for them to work on. So more details about that in the future. But version 1.5 for now, again, the goal is a couple of things. The goal is to basically make it more tanky so that it could survive visitors to those outreach events. Also more flashy. One thing I have found is when I bring both the Ozobots and the Stinger, the students that visit tend to be more interested in the Ozobots, and I think part of that is because the Ozobots literally have flashing LEDs on them. That's about all I can figure, because frankly, the ones we built are so much cooler than those are. So the idea is going to be to take something like this and add some pizzazz, some flair. Again, it's electrically the same. About the only difference I have in my head is literally adding some LEDs just to give it some literal flash. But the place that I would normally start, we used to call it, when I was in engineering school, they used to call it a priori decisions, a fancy Latin term that honestly I don't even remember what it means. But the way that I always took, or what I always took it to mean was, you got to start somewhere, right? And sort of the entire basis of this version 1.5 design is that circuit board. And I've got it, I actually did it in KiCad. This is the schematic for the board. I'm going to grab the PCB. And again, I'm not an expert in PCB design either, so some electrical engineer someday will probably look at this and yell at me. Exit before saving, load, sure, why not? There we go. So the PCB design is here, and I'm just going to export this guy because I don't think when I downloaded it from my work computer, I don't believe that I might have a step file in here. Let me check first. So let's extract the zip that I saved earlier. I did have a step file. So there's already a step file. I now have it extracted. So I'm going to go ahead and close KiCad then, because I don't need to reinvent the wheel. And go ahead and import that guy. Import. Now, as I was playing around, we want downloads, the Stinger 1.7, and somewhere in here is a step file. That guy. I noticed I went through several iterations of the PCB. This one that I actually have in my hand, I did. This was version 1.6, I called it, which is actually the second version of the PCB. It's now on version 1.7 because each time I make electrical mistakes, and I'm willing to admit that. This one, this is the motor driver board on the side. I completely forgot that I was looking at the schematic of the board upside down. So the pins on the custom PCB were backwards, which wasn't good for anybody. The second one fixed that. The current one, which I don't have a current one, the electrically is fine. I was actually testing it in the lab this afternoon. Is electrically sound this time, but then I forgot to check the box for a red PCB. Because of course, I mean, part of these projects, especially when they're destined to sort of bring visibility, part of the goal in a design is some bling. And since Baker's colors are red, red PCBs are a good thing, and I forgot. So version 1.7 will have to be redone, and I'll just have to check the box this time for red. But the actual import. So we're going to import clear polycarbonate. I agree with that. That would be awesome. There's got to be a way I can make that a student project too. So one thing, I'll be honest, when it comes to the import, we get these options, and by default it popped up without this create a composite part checked. I will be honest, I'm not entirely sure when this is necessary and when it is not. Occasionally, on some of the models that I was playing around with in between the older sort of first look video and today, when you check this, sometimes it comes in where all the parts come in as a part. Like this thing is going to come in with all of the female headers and all of uh, the switch, the power switch, all the components that are on the board are going to come in here. And sometimes, depending on, I guess, how the model was originally set up, if you click this, it'll come in as just one part. Otherwise, I believe when I import this, I'm going to get an assembly. So let's see, we'll import it. It takes a minute for it to sort of think about it. And you can always check, and you can actually see the notifications, the various things I was playing with before today. But the notifications up here toward the right give us, an idea of what's happening. So it's going to take it a minute to upload. And unfortunately, we have to wait. And I'm starting here, like I said, you got to start somewhere. And again, since the basis of this whole redesign thing is sort of that PCB, we're designing around that. That's the logical place in my mind to start. So we'll give that. All right, we should be done. So now I've got some tabs. Assembly 1, I don't even know what that is. We haven't created that yet, but I'm going to drag it over here because we might as well use that as our main assembly. Now we have parts. So when I click on the Stinger 1.7 parts, these are, all the components it wants to throw in, but they're all kind of mashed on top of each other. The actual assembly comes in and looks correct. Now, I cheated. Like, for instance, this is a power switch. This is very obviously not a power switch model. It's just a pin socket. But I cheated and used it because it had the same pin spacing as the power switch I actually did use on the PCB. So the components here, I think other than that, well, these should have been female. Other than that, I think everything is correct. But it's not so much the components on this that are important, so much as the sort of the layout of the PCB itself. So that's okay. There is one thing I want to do, and this is a thing that I noticed about Onshape. So in SolidWorks, I'm going to bring this assembly into the main assembly of this robot. SolidWorks, when you do that, sort of assumes that any assembly you bring in can't move. Right? I'm going to move the assembly as a whole piece. Onshape doesn't really do that. Let's see if I can show it in here without another part to mate it to. So let's bring in, I'm up here and just going to click Insert and Assemblies. Bring in that assembly. All right, and I'm just going to drop it in space and just see if I can sort of show what I've noticed. So I want to take this circle. I want to, for now, mate it to the origin. Is it going to let me do that? No, it does not. Well, oh no, it lost the circle. That's right. Workflow. There we go. Workflow in Onshape is different than in SolidWorks. So in SolidWorks, you can click both parts and then hit mate. Here, you have to hit mate and then click both parts. But so if I accept that, it took the solder mask, the green on the bottom, and moved it alone without moving the rest of the pieces, which is bad because, I'm lazy. I'm a lazy mechanical designer. I don't want to move all this by hand. So I'm going to get out of here. I'm going to go ahead and delete that guy. What I noticed to fix that is I am going to select the bottom. It doesn't really matter which part. And in fact, I don't think I want to select the bottom. So we have a bunch of surfaces here in our model tree. And I'm actually just going to click that first part, the PCB. So that should just be the gray. Click off. The gray here should be what's selected when I selected this. And I'm going to fix that. I don't really care in this assembly where the origin is because I'm really only ever going to use this as a sub-assembly. So, but once it's fixed, I'm then going to select everybody. And this has got a lot of surfaces because I told KiCad to export all the writing. And every piece of silkscreen gets its own surface. I'm going to come all the way down, shift, select it all. There's a little group icon here. So when I click that, it all pops into the group, create the group, and now if I drop it into this assembly, insert assemblies. Where are we? Right there. Now, if I accept and mate that guy, and let's switch to fastened this time, because that should also stop the rotation. Now, because they were grouped, that's what causes Onshape to sort of treat this as one piece. So I'm going to leave, yeah, that's okay. I can leave that there for now. I'm going to leave that there for now. And I'm going to hop into this part studio. And I'm going to rename it. I guess we could just call it chassis? Question mark. Let's call it chassis. And we're just going to start, modeling the chassis. Now, what is handy is I probably shouldn't have jumped the gun and closed KiCad so quick. So let's reopen that. And I want my 1.7 PCB, which is odd because I didn't change the names down here, but this should be the right guy. Yep. And the grid here I have set to a 0.1 inch spacing, which is the spacing, actually it's set to half of that, but it's the spacing between these holes. So I know when I take some measurements off of this to sort of lay out where things are going to go, that this, the measurements I'm getting off of here are accurate, that I can dump then into Onshape. So I guess I'll go ahead and do that. Now, since I am basing it around this PCB, what I would normally do is I'm going to go ahead and select the top. What I would normally do is create a sketch that shows me and I'm going to switch my view here to the top, that I'm going to create a sketch that's going to sort of serve as the basis of everything that goes into this part later. So it's basically going to be a sketch that is the outline of that PCB. So the PCB is a rectangle, so we grab a rectangle, and off the top of my head I have no idea what the dimensions were, so we're going to go back here. And I can get them either way. I can get them out of this, and I suppose since I promised an Onshape video, I should get them out of Onshape. So I can do the same thing. I'm going to go to my assembly and just select these surfaces, and I get a measurement down here in the bottom right, so it's 4.1 wide. Oops, I can see SolidWorks workflow. I keep wanting to Alt-Tab. 4.1 wide, 4.1, and keep wanting to Alt-Tab. You'll catch a lot of that. I've been using SolidWorks now. I was looking back, and the first version, at least that I remember using of SolidWorks, was 2005. So that's a cool 20 years of being almost exclusively in SolidWorks. 4.9. And so there's a lot of workflow habits that, Onshape is very, very similar. Like, you can figure out most of the stuff that's going on if you're used to it. Any other 3D CAD. But it is... it's the workflow things, the habits that... So I'm going to grab, and I don't know, can I set a plane as a midpoint? Let's see. Midpoint. Will not. Line or arc. Okay. So I'm going to drop a point at the midpoint of each line, the sort of the top line and the bottom. Midpoint, midpoint. And when it lights up with that little square, that's telling me I've got the midpoint. I can also check that's the midpoint constraint symbol, right? If I come up here to the constraints, midpoint, right? So if I select that or hover over that point, it shows me that it is midpoint. Now, to center this thing, because I want to at least start out centered on these two planes, because that opens up options for symmetry later. And I'm already thinking ahead to when the motors come into play, because there's a motor on the left and right sides, and I really don't want to model, from scratch motor mounts on each side. So if I center it on these planes, that opens up some options where I can just mirror features from one side to the other. So I'm going to select that point in a plane and do coincident, which is U, and oops, coincident, which is you. Now we're centered. Now, just for grins, I don't... Yeah, why not? I mean, because normally, if this were just... Normally, I would create a sketch. And in fact, I would create a sketch, and normally, I mean, my normal thought process, because this is the PCB layout, would be to set it to construction. Just in my head later, looking at it, oh, I can't do that by selecting the area? Oh, man. So I'll select each individual line. Fine. Be that way. I would set it to construction just so that later when I look at this sketch, because all it ever is going to be a reference. I would just set it to construction so it doesn't confuse me later, frankly. I'm easily confused. So let's see. I want points here, here, and these are going to end up being the locations for the mounting screw holes on my PCB, right? These 4 holes. And like I said, I'll get the actual measurements from Onshape. So the holes, if we look at it, it doesn't really matter what I'm thinking about. It doesn't really matter what direction this thing's oriented in, this way or this way. Just make sure, in fact, for consistency's sake, let's make sure we're looking at the top. And if we look at the top all the time, we'll know what sort of orientation we're in. So ultimately, when this thing mounts, this will be the rear of the robot, the top of this. So we're sort of looking at that screenshot in the webcam. There we go, in this orientation. So all the ports and whatnot for connections, power ports, programming ports, all that good stuff will be back up here on the top. And this will be the top of this view will be the rear of the robot. So measurements, let's see. These, I believe, should be in line. So selecting, make sure I only selected that. That's the, so far in my sort of Onshape learning, the biggest SolidWorks habit to break is when you have something selected, just hitting escape to deselect it, because it doesn't work here. You have to click off into space to get it, deselected. So select the whole, select that top edge, and minimum distance doesn't work. Notice it lights up that black dotted line. I don't want the edge to edge distance. I want to go in here and I want the center distance, which is right at 1/2 inch. So if I come back to the chassis, right at 1/2 inch. So we'll go here, 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 0.5. One feature I do like is it just did it to me, and it took me a minute to decide as I was playing around off camera. It took me a minute to decide that I like it. If I select, let's get another dimension. If I select the point and the line, because it's construction, if I pop over here with my cursor, it automatically wants to treat that as a center line, which gives me a diameter. Good if you know that. Bad if you expect that to be the full dimension, because, again, lots of SolidWorks, lots of years getting used to SolidWorks workflow, it doesn't do that automatically unless you tell it this is a center line. So these, I believe, they're already constrained to be horizontal. Let's just double check that they actually are in line, and probably the fastest way to do that is to just check, again, center distances in Y is green, center distance in green should be 0. It is, so they're in line, so the horizontal constraint works. They are not equally spaced. Now the bottom ones are equally spaced. They're the same distance from the long edges. This one is not. I had to move it in to clear the power board. So this one, let's see, where does this one fall? From here. Again, I don't want minimum distance. I want the center distance. So that's 0.3 in. 0.3 in. And the other one is what in. We got to go from this edge. Now, ordinarily, I would like to dimension off the same edge, but in this case, I think it makes more sense to do it this way. It's 0.7 in. So 0.7 in from this edge. Then the bottom ones, let's check. The bottom ones, I believe these are vertically in line. center distance, and that's the X. So I'm looking for the red center distance should be 0. It is. All right, and then what is this guy off the bottom? Center distance is 0.3. So it's actually close. Whoops. There's that Alt tab again. You gotta catch me. So these guys are vertical, so I can just select them both rather than dimension and just add a vertical constraint. Pop that line or that dot over. Grab a dimension, and this was not the top one was 0.5. This is 0.3. Okay. These I know are horizontally in line, so I can add that constraint. And then what is that in from this edge here to here is center distance 0.3 in. Cool. 0.3. Where are you? Dimension 0.3. All right, so everybody is locked down. I'm going to accept that sketch. And this sketch is just going to live here forever. I may hide it. For various times, but for the most part, I'm going to leave it visible because this is going to let me reference later sort of where that PCB lives. So I'm going to create another sketch on the top now to start building out the body of this thing. And what I have in mind, like I said, the original, this version, which is great. Again, you did a great job designing this. The student did, and I tried to mimic it or build off of it. And I just decided we could get sort of nuts. Again, when we're 3D printing, not really held to the rules that everything has to be accessible by an end mill, right? So basically what I'm going to do is start building out a place for the board to sit, and then effectively my thought process is to start, and I'm staring at this thing, trying to become inspired. Half of this is just art at this stage, right? Not a lot of science yet, but I'm thinking just a place for the board to sit, sort of just a tray, and then to just sort of start hanging things off of it for the various motors and sensors and whatnot, and see where we end up, and sort of see how cool we can make it look when it all comes together. So that's, I think, the approach I'm going to take, rather than starting with a big block, which is what I did the first time, by the way. Start with a big block and carve away at it. I think I'm going to start with as little material as possible and add to it. So that's sort of where my head's at. So let's grab the top plane again, create another sketch, and just start, building this thing out. So I'm going to add a rectangle. Now, I'll be honest, the 3D printers that I have at Baker in the lab, I am not as sort of intimate with as I am my personal printer that I've got sitting over here in the corner. The printer here, I know for a fact, I can hold at least 3/1000 of clearance. I don't know that for a fact on the ones in my lab. I haven't played with them and tested clearances yet, and tolerances. So I'm thinking of leaving something big-ish, probably 15/1000 aside. That sounds okay. But that's what this sketch, this construction sketch exists for. So I can just do something like this. And actually, I jumped ahead because I don't want to do that yet. The 15 thou. I will. This needs to be big enough to actually hold the board, which is good. See, this means I don't have to undo anything yet. So from here to here, if I want 15 thou, and I'm gonna end up making this a little tray with a little cutout into it. If I want 15,000ths, I mean, what looks right? A 1/4 inch maybe. And of course everything gets really huge because that's the first dimension I put in. Let's try a 1/4 all around first and see how we'd like that. I probably want less than a 1/4 on the top. 2.5. I probably want less than a 1/4 of an inch at the top because, again, the top is this thing is oriented this way, and I want these ports on the Arduino accessible. We're going to have to be able to plug a programming cable in there, a USB cable. Um, yeah, so let's make that actually thinner. Let's just start out that way and assume we want that thinner, and we can go 1 point or go 1/8 of an inch. Now, again, I mean, that's fairly accessible already. Even on this, which is like a 1/2 an inch, it's accessible. But by moving that back, I think it'll get to be even more so. And I'm basically going to keep, at least for what I'm doing right here, I'm going to keep this same idea where the PCB, I don't know how well it shows up on webcam. I could probably even pop back into full screen. The PCB, if I get it, the angles right, the PCB actually sits flush. So it's nice and tucked in. And that's basically what I'm going for here. A hunk of plastic, and then I will cut in a pocket for the PCB, and probably have to add a little material. I don't have a blank PCB, but the Arduino is a good example. The Arduino, everywhere that it has a solder joint, it's got little contacts that stick through the solder. So the same thing with the red PCB, the custom PCB, it can't sit flush on plastic. There's solder joints under there. So we need a pocket for the board to sit in, but then we also need recesses for those solder joints. And we can take a pretty good ballpark estimate at what that needs to be. But for now, actually, I need to do that now because I need my next thought. I'm going to end up extruding this, so let's accept the sketch. And I'll clean this up. So this thing, when I extrude this, let's select that sketch and extrude it, is going to create a rectangle. It is not, trust me, by the time I'm done, not going to remain square. I mean, square is not pretty. So much like this one, it will get fillets just about everywhere I could squeeze them in. But the one thing that I always do in my designs is I sort of wait till the very end for fillets, because and here I am forgetting to switch over to the share to actually show what I was talking about. See, you can definitely tell I'm not a professional streamer. It'll get fillets. It'll get fillets toward the end. The problem I have noticed over the years, if I fill it too early, inevitably I want to reference like a dimension to this edge, but it's not there anymore because it's round, and then it causes all kinds of problems. So I try to save the fillets for last. Good question. Threaded inserts. Yes. So the original design, I recommended to them on the original not to use threaded inserts, and none of these holes use them. I have had very good luck with 3D prints over the years with screws just holding into the PLA, and it works well. I just honestly, usually when I design a part to be 3D printed that I know is going to get a screw, I'll just size the hole in my solid model to match what the tap charts say the tap drill size is. So if it's a size 30 drill, I'll use a size 30 hole in my solid model, and usually the screw threads bite right into that. Again, though, with this, it works. It's great. But again, the problem is the insane amount of violence that these things see when sort of the public gets a hold of them. So a lot of these, like this whole black upper chassis wiggles. I don't think anything is actually straight up pulled out yet. But yes, there will be threaded inserts in every single hole in this particular design. Like I said, this one does not have them. I don't remember. We played around with some of them on the redesign when he designed this. You could see sort of in the there it is, in the motor pocket, threaded holes for those, or threaded inserts for those rather. So, and that was sort of one of the things that I wanted to, as I'm going through this sort of walkthrough, so I could sort of divert, my thought process when I get there. Let's go here and let's go to McMaster Car. And hey, look, I was already looking at. So the best thing I have found are these heat set inserts. And literally just search for inserts here, it'll pop up. And these are I use these a ton, um, and honestly, most of the time I don't even use heat. So I'll just grab these, sort of press them in the hole, and for most of the things I've ever done, they've been just fine that way. These I will use heat. They're pretty simple. If I click on one of the details, let's just grab one. If I click in here, related products, soldering installation tips. So these are tips that actually go in a soldering iron. The insert fits on the end. You heat it up and push it in, so then the plastic melts around these knurls, and I mean it's insane amounts of hold. So, but like I said, I've had fairly good luck in the past, just sort of pushing them in. Um, I will probably, in order to make this as robust a final product as it can be, I will probably end up actually using the heat. So, but yes, absolutely, there will be threaded inserts on every single hole I do on this thing. Um, which adds it adds a level of complexity, which is a cool thing to think through too when I get there, is because these things have specifications, right? If I make, oh, it was already expanded. It has it tells you what diameter hole to make it, and it also gives you a minimum material thickness. So, when I'm designing for these, I need to make sure that I'm actually, meeting these specs. That'll give you the best results at the end of the day. So we'll get there. I'm not going to download these yet until I actually start popping holes into this. But yes, absolutely, we will be threading inserts. So our extrusion here, 1 inch is huge. 1 inch is huge. And the reason I say that, again, if I can pop, it'll be easier for now if I pop the Arduino off of this prototype, just for show and tell purposes. So if I pop you off, so effectively the underside of our PCB is going to have the same, and I'm going to kick back to full screen, make that a little bigger. Our PCB at the back has the same, come on, give me some focus, has the same, raised contacts after we get done soldering. So 1 inch is kind of nuts because we don't need an inch to clear those, right? We need I need a pocket deep enough for the board, which I'll have to measure the solid model. I want to say is like 45 thousandths of an inch. So I want a pocket deep enough to set the board, our custom PCB, right? But to set the board down in, then it needs enough material so I can cut out holes, pockets, whatever it ends up looking like, for these soldered contacts on the bottom, which isn't very much. It's not much deeper, even though, I soldered this, so it's nowhere near as good looking as Arduino's. But we need enough material so I can cut pockets for that, and enough material for to have a bottom of those pockets. And then really what I'm thinking is that's it as far as the whole thing thickness. Then the screw holes, the mounting holes, we really only need thicker material to accept those inserts. We really only need that in the locations where the screws are. So what I'm kind of thinking is make this whole rectangle as thin as possible, and then just sort of add extra material where the screws are going to end up, to get us that extra thickness that we're going to need. So I think that's the play. Just, personal preference. I tend to think ahead to how these parts are going to go together. I don't like that extruding up. I would rather extrude it down, and that's just the way my head works, because in my head this fits into an assembly, and the PCB is the driving factor. That sits here. This should be the top, right? That's just how my head works. So thickness, what do we need? What do we need for thickness? First, I got to get the thickness of that PCB, which, like I said, I think is 60 thousandths. And actually, in this case, this is a terrible time for me to measure off the model, because, all right, so it's 60, that's probably in millimeters, and that's the other reason I keep a calculator handy. My head never converted to millimeters. So 0.063 times 25.4. So 1.6 millimeters is what the solid model is, but the problem is doing it this way. That's the default in KiCad, and that's not necessarily what I ordered, because the website that you order these PCBs off of, you can change the thickness sort of at will. You just enter it on the order form how thick you want it. So probably not the best time to measure it, but I mean, if we go with 60 thou, it's probably close enough. I don't want to pop the board out of this, partly because that's riveting, streaming, watching me unscrew a PCB. But if I measure that, we'll start with 60 thousandths. It can be adjusted later. So I'm going to make a cutout that's 60 thousandths in. Well, no, because I can't. I haven't finished. So I haven't finished extruding that. See, this is how my mind works, back and forth, jumping ahead. So on my paper, handy dandy scratch pad, we've got 60 thousandths for the board is what we need. If I go back to this assembly, I can get an estimate, because these are the actual components. So if I take a look at how tall these pins are sticking down, let's look at the front. Which ones are the tallest? Kind of a tie. No, these guys are the back. I don't even know. Those are the fuse holders? Nope, those are the motor plugs, I think. But anyway, if I select the bottom of the board and that, it should give me an estimate of the height. So we'll call it 70 thousandths. So we need 70 thousandths. Now, on these, because I don't trust it, frankly, that's accurate. I don't know what the variation is. I don't know the KiCad. I mean, these were automatically generated by KiCad from their library. I don't trust it. So if it's 70 thousandths on this model, I'm probably going to call it 100, just to make sure that after we print this thing, and it takes 2 days to print or whatever it's going to take, that we have the clearance on the first shot, and that's not the thing that's holding us up. So I'll probably add 100. So we're at 160, 1.6 right now, and I'm thinking, if off the top of my head, just at random, I'm thinking of 1/8 of an inch bottom. I mean, it doesn't need to be ridiculously thick. That would bring us to what, 385, and add 15 just because I like round numbers. So call it, 285. So call it 0.3. 285. Call it 0.3 and see how that looks. So, I mean, that's a lot better than an inch. I mean, it'll at least be a lot thinner. So we've got that. Now I'll go ahead and create a cutout for the board, and this is sort of where I jumped ahead to like 10 minutes ago. Same surface. I'm going to sketch a rectangle again, and in this is where the clearance of the board sort of matters. Like I said, if I really, really, really knew the tolerances that these printers could hold, I would make it a lot tighter than this, but I'm honestly thinking 15 thousandths is plenty. We should be able to hold that. And I mean, of all the things I've noticed in Onshape, this is probably the only one that really annoys me, is how much things shrink when you put that first dimension in, or grow. I mean, either way. That's probably the only real annoyance I have, honestly. So put 0.15. And this pocket, the corners anyway, I can leave square because the PCB corners are square. And that's a thing I have screwed up in the past. Like a lot of this stuff, there's a lot of the thought process I go through doing this stuff is because I have been burned before. So if I go 4 inches, so remember, this dotted line is the outline of the PCB, right? And it does have square corners. And I have made the mistake in the past where I will come in and where's the fillet? Sketch fillet right there. Where I'll fillet this, and suddenly my PCB doesn't fit because the PCB didn't have, or whatever parts going in here, right? It has square corners, and the hole doesn't have square corners anymore. So make sure that when you're doing that, you pay attention to, the thing that's actually fitting in the cutout you're making, whether you fillet those or not. So those will stay square. These outer ones will get a pretty healthy radius when we're done. At least I think. I mean, we're not there yet. But for appearances, radiuses will look good. But again, when there's something that has to fit in here that's square, it should probably stay square. So, accept that sketch. I'm going to extrude, and we're going to remove material. Also not going to be an inch deep. What did I say it needed to be? We need to go 100. But does that really work? So the thought I'm having, if I cut out that 100,000ths, the problem I have is, oh no, that shouldn't be that should be the 60. I was jumping ahead in my head too. That should be the 60,000ths for the board, just the board. So where my head was going with the 100 was the clearance for the pins, and I was thinking if I cut the full 100 out, then my board there's no material where the screws go, right? For the board to kind of sit on, which, my head jumped way ahead, and that would be a bad thing. But it's not actually an issue yet. It would have been if I'd have, gone through with it. So now in this assembly, I'm going to go ahead and bring the chassis in at this point. So I'm going to insert the chassis because I am far enough along where I have enough features on this to actually lock it in place with respect to the PCB. So I'm going to use a planar mate to lock it to the bottom of the PCB. And right now, these pins will sort of interfere with this. That's fine. That's okay. That's cool, right? They are like sticking into plastic now, which is okay. We'll get there. We'll fix it. Now I'm going to use width mates. I love width mates. I didn't see them when I was playing around with Onshape the first time, but widths are awesome. Widths allow you to perfectly center, assembly objects with respect to another. So just like with SolidWorks, it doesn't really matter what the tab or the width is. They got to be so the tab has to be two edges on the same part. The width has to be two edges on the same part. So for the tab, I'm going to select the two edges of the board and this edge of the board, right? So I've got two tabs. The width, I'm going to select the two sides of my chassis. Doesn't look much like a chassis yet, but we'll get there. All right, notice it's slid over. That board is now centered in that direction. Anyway, we'll accept that. Throw another width at it. Where are you? Width. Got to get my icon straight. Grab the two edges of the board. Two edges of the board. And then the two edges of the chassis. We should see it pop right into place, I hope. Oh, it helps if you select the width mate. Look at that. So go back and reselect my chassis, and now we should see it magically pop into place, I hope. Did we not? Part one, part. Because this is the chassis. This is the board. The width is the board. So I did it backwards from what I did the first time. Oh, the joys of, screwing up live, right? So there we go. We accept that. This guy now, the degrees of freedom symbol. So where's my other? This stinger assembly, if we look. Can I make that bigger? I can. Well, those are all grouped. They don't have degrees of freedom anymore. Anyway, what I was going to show is when it came in originally here, it had here's my taskbar. It had a little icon next to it that looked like a set of axes, and that was the it has degrees of freedom sort of warning, and it's now gone. It's locked down, like you can't drag it anywhere. So we're good. Now, the reason I put it in at this stage was to make the cutouts for the various things that will have tabs. or pins or whatever. Honestly, again, not an electrical engineer. Whatever the underside of those connectors is called, I would call them probably pins. But we can make the cutouts now. And the reason I did it this way is I'm going to right click on this guy and I'm going to edit it in context. Now, just because I'm editing in context does not mean I'm going to add dimension in context. So in context dimensions would be if I took, well, first of all, I need to select that surface, right? The surface we're sitting on. I'm going to start a sketch. An in context dimension would be if I dropped something in here and dimensioned it to something on the PCB, like say this connector. If I do that, new assembly context created. I do not want to do that. Pardon me, still getting over a cough. I don't want to do that. In fact, now I got to go back and re-edit in context. I don't want to do that. I've never been a huge fan of that sort of, if we call it a style or technique or whatever we call it. Never been a huge fan of it because things get sort of I don't know if messy is the right word. It gets kind of hard to keep track of changes, I guess is the best way that the thing that has burned me in the past, let's put it that way. Because if I dimension, let's say I want a hole here and I want that hole, off of this pin and I dimension it that way. If I move this pin, like if I shift this whole Arduino over this way, my hole is also going to move. Maybe I didn't want that to happen, but that's the bigger problem is if I didn't want it to happen, it happened, and I didn't know it because I forgot that I put the in context dimension in there. So those in context references can cascade through an entire design. And the problem is you won't actually know what changed. And I've actually seen it happen with professional machine builders because it's fast, right? I could dimension off of these pins. I could drop holes in here, tell them to, put the holes off of this PCB. That's great. I've seen guys do that with entire machine designs, like industrial, assembly equipment, and build the whole thing with those references like that. And then they'll change, a tooling plate that sits on top, and all the other holes will change, except they forgot about that, and they didn't get new parts machined, and now nothing fits. So I get a little leery. About actual in-context dimensions, but in-context editing is kind of awesome because now I can just sort of grab rectangles. And do I want it to be a rectangle or do I want it to be cooler than that? Because we can do pretty funky shapes in here. Oh, let's see. That's it. Command decision. We're going to go cooler than that. We're going to make it a complex shape. I'm not going to use splines, I don't think. I think I'm just going to use lines. And then fillet them later. So, yeah, I'm just going to start. These are good. So the sketch I'm drawing is what's going to end up getting cut out. That's a thing to bear in mind, that we want to make sure we leave material around the screws, right? We leave material, importantly, close to the pins because things are going to plug into these. We want material, plastic underneath there to support, so we're not just pushing on the board. This one might not be so important. We're going to do it anyway. This one definitely. So we want to leave some material around where things plug in. So keeping in mind that what I end up outlining is going to end up be what I cut away. I mean, let's do it, I guess. So knowing that I have to be shy of those pins, also I need to be careful because once I start sketching, it will want to try to snap lines to like the printing and stuff on this PCB. So I'm going to be careful of that, but I'm just going to start drawing lines of the stuff I want to cut away. So I got to cut away here. Well, let's go here instead. I got to cut away here. Now I got to think about this because it's sort of a reverse way of thinking. I'm not thinking about what I want to leave behind. I'm thinking about what I want to cut. So I wonder maybe the original way I did it. Maybe the original way I was going to do it, where I just outline everything. And I can outline everything and make it construction and then sort of connect the dots. And that might be the way to go. And there's going to be a lot of outlining. Now, one thing I do want to be careful of, because another thing I'm not a fan of, and I absolutely hate it in SolidWorks as well, so this isn't just an Onshape thing, is I hate it when it adds automatic constraints. Like if I click here to draw this rectangle, it's going to want to lock this edge of the rectangle I draw vertically to this point, and I hate those types of constraints. Because eventually, as you're dimensioning, like I'm going to end up, if I box in every one of these connectors, I'm going to have like 30 rectangles on this thing. And when I start dimensioning them, eventually what will happen is I'm going to add a dimension that's going to break the whole sketch. And I'm not going to know why. And inevitably, it'll be one of those automatic constraints. So I hate them. I have not dug deep enough yet to see if there's a way to turn them off. I know in SolidWorks there are. It's buried in the preferences somewhere. But I honestly think that's just what I'm going to do, is outline everything I want to cut away. I think I'm going to set it all to construction and then sort of connect the dots either with a spline, maybe a spline. I don't know. Maybe I won't connect the dots. I don't know. It's fluid, you know. It's like I said, it's at this point literally more art than science. We've got some, you know, sciency engineering type concerns to take into account, like we got to have things a certain size, right? But beyond that, I mean, oops, see, automatic is straight, and right now parallel is fine. Where did it throw it? Coincidence fine, because that's going to be the corner. Which one did it make? Right there. See how it lights up the sort of that bottom rectangle. I don't want that. Oop, go away. Where are you? That one. You want to get rid of that one. I want this to be vertical. I do not want it to be vertical locked down to this rectangle at all. So we'll go here, we'll keep doing it, make sure we avoid those sort of automatic constraints. And again, I'm being very careful not to sort of grab. Occasionally it wants to snap to things on the PCB, and I do not want to do that. It's a thing I very much do not want to do. So, and actually, you know, for this side, there's so little space. This is, so the spacing on those pins is 100 thousandths, 0.1 inches, 2.54 millimeters. So that means from here, from this pin to this pin, the center to center is only 0.2 inches. There's not going to be a lot of plastic that we could fit in there anyway. So, I mean, for these vertical runs on the Arduino, I'm just going to rectangle the whole thing and not bother splitting it up. Because there's not a ton of plastic that's going to fit in there anyway. Now, most of these things, like this guy, even though that's, like I said, this is a female socket where it should be a switch. Well, before we do any of that, I missed two. I missed the angled. Can't use a rectangle for that. We got to use an aligned rectangle for that. We're going to do this and get it close. Just close. I'll clean it up in a minute. Just close. Now, most of these things, like these headers, female and male both, have the same size pins, which theoretically should mean that they need the same size clearance. So I'm going to take the skinny edge of all of these and set them equal. That means I only have to dimension that once, I hope. And I hit control. There's a SolidWorks workflow thing. You don't need to hold control in Onshape, buddy. So I'm going to grab the skinny edge of everything that goes around one of those headers, including the switch, because like I said, it has the same spacing. That skinny edge, that skinny edge, that skinny edge, not this skinny edge because it's double. And is that all of them? That looks like all of them. And I'm going to just set those equal. And everything got huge, probably because of whatever I picked first. I can shrink it. And I mean, at this point, I'm just going to start guessing at what looks good. Now, if I sort of look at the PCB, the solder pads on this thing, the solder blob is not um, very big because the solder pads are not very big. The solder blob is only ever going to be, I mean, it might be a little bigger than the diameter of the pad, but I mean, honestly, not by much. And if I'm looking at this thing, realistically, all the more clearance I need is the size of this black outline, right, on either side. That's really all the more width I need. If I get, again, let's switch back to the full screen. If I get real close and hopefully focus, maybe, no, help me out a little. Anyway, you see sort of an open one over here that I didn't solder yet. And those pads are well within the outline on the board, which means, and the outline is actually on this outside of the black plastic that mounts those pins. So as long as my cutouts for clearance clear that white outline, we have plenty of space. So we don't need a ton of width here. So what is it now? That's 0.3. I don't know, quarter. Oh, sure, and then everything moves. I love you, Onshape. Everybody moved. Let's go back. Why does that look like it actually got bigger? Did it get bigger? We can actually go smaller. I like I said, my brain never switched to metric. I'm still very much an imperial kind of measurement guys. 1875 looks kind of funny to folks that aren't used to imperial measurements, but 1875 is a pretty standard imperial measurement. What do we get if we go to an eighth? 125? Does everything fly so far every time I change dimension? Yeah, I mean, that's okay. Because, like I said, as long as we're outside of this white, which is the printing on the board, and that printing is accurate, that's, I mean, literally, this is what I sent them to print on the board. So what I have in front of me physically is going to match where the printing on this model is. So I'm confident in that. My concern, and the whole, like I said, the whole point of this stream is to think through this sort of thought process that I go through. My concern going this tight is tolerance stack-ups. So, I mean, if these holes end up off by a little bit and things move over a little bit, we could end up hitting a wall here, and I don't want that. So I think I'm going to stick with the 1875. Oh, sure, fly the other way. That's, you know, annoying. And that, I mean, it's fat compared to the clearance we actually need. But at the end of the day, more clearance doesn't really hurt anybody in this case. We just want to make sure we got plenty of opening to fit our board in. So, did I not set the width of this guy? Or did that guy belong up here to one of these? See, that's the problem. All right. This is, you know, a design lesson on the fly. I'm just going to go ahead and delete everybody and do them one at a time. Probably going to work out better for my sanity. I will probably swear less. Thanks. Professional streamer, right? Forgetting to switch back to the CAD screen. So I ended up deleting everything I did. You know, nothing exciting to see there. Blow it all away. Mostly because it kept moving around on me when I changed dimensions, and I decided it would probably be easier to do this way. So here again, grabbing, remember I've got my sort of board layout sketch is still showing. That's the gray line you can kind of sort of see that lights up orange, the dotted line. So when I grab that, I'm not dimensioning the PCB, that or to the PCB assembly model. That's important to remember. It doesn't really matter, I mean, whether I would do it to the dotted line or to the actual plastic. I'm inclined to do it to the actual plastic, just because I mean, technically speaking, the dotted line doesn't exist. I mean, that was the whole point of the dotted line. And then from here, I'm just going to try to kind of center it to this. again, without the quick and dirty way. I will show it because, again, it's a thing. It's allowed. People do it all the time. The quick and dirty way to get this thing, if I wanted this cut out perfectly centered with this, would be to grab a line, drop it on the center of this rectangle, and will it actually let me, yes, grab here, and hit center, midpoint. Okay, it created a context. If I click this down, make it vertical, oh look, it's centered, right? That's quick. That's easy. And actually, you know what? I'm not doing this for production. Like, I'm not gonna, sell this thing and make billions of these things. So why can't I do it that way? I don't see a reason I can't do it that way. Is there a reason I can't do it that way? I don't think there's a reason I can't do it that way. So guess what? I'm going to do it that way. Ordinarily, that is not my normal workflow. Like, I avoid, the in-context stuff kind of religiously. But yeah, I'm going to leave it that way. I am going to make this, well, everything's going to end up construction, so I might as well leave it for now. Everything I do will be construction in a minute. So let's center this guy here. Here, and it doesn't like to snap on accident. It doesn't, I'm trying. It doesn't like to snap to the PCB on accident, but it will this way. And so there is no line here in the center, but this should be the center. If I hit not midpoint, but if I coincident that guy and make you horizontal. Okay, we're still not locked down now, but we are centered. We're still not locked down because I haven't set the height. I guess. I mean, since I'm doing all the in-context stuff anyway, what's that distance? 80,000th? So why don't I just do it that way? Excuse me? Why don't I just, if I'm going to, why don't we go all in on the in-context stuff? 80,000, whoops. Yes, I'm involved, or aware, thank you, that it requires me to hit. All right, where did the 80 come? Was I making things up? I'll go 40. 40 looks good to me. Do it on the top too, and that way I only have to dimension the two. The bottom one locks in place because I've already got it centered. I kind of like that. So yeah, let's do it. Now, we'll get there. I was going to say, what would be the middle of this mess going on here? Because one thing, I will warn you, should you use the Arduino Giga R1 board, which, again, I'm not an electrical engineer. I'm not an expert on Arduino. It's my understanding that this footprint for these connectors is the same footprint as their Mega board. And one of the reasons that this PCB is version 1.6 is version 1.5 assumed that all of these gaps where Arduino doesn't have a pin are equally spaced, and it turns out they are not. Notice that this guy is a lot closer than this guy. And it took me longer than I would like to admit trying to plug this in. So won't those midpoints on the sketches interfere with making cuts? Yes, but again, I think, now this may not work. Don't get me wrong, what I have in my head may not work. My plan is to outline everybody in a similar way and then make everything construction. Like literally everything. Everything I'm doing now, just, highlight it all in construction. Boom. Right? And then I'm thinking of like connecting the dots. So like I know I want here cut out, right here, but then I want material down to here, right? So that's where I'm thinking of going. Let's get rid of that line before I forget it's there. That's where I'm thinking of going, and that's why I agree with you. Yes, very much so. It would interfere with the cuts. But if this plan works, and I am not saying it will, that it ultimately won't matter. So anyway, that's the idea that I'm shooting for. And like I said, I wouldn't normally do, whoop, I don't want angled, I want corners again. So let's drop one here. And again, like I might as well might as well just, continue the in context theme. So let's give it a dimension. I'd like to go off the plastic, I think, rather than the print. I mean, I'm going a little nuts on this particular one, but not too nuts. I mean, some things have to be sound. Um, and then we can center it, and that should, right, those two dimensions should define everybody if everybody's centered. Grab you, you won't snap there on your own. That might be, I mean, like I said, I don't use these midpoint. Boom. I don't use the in context stuff enough to call that an annoyance. Because how can it be annoying if it's a thing you never do? But it may be to some people that do it a lot, that are used to SolidWorks just sort of doing it for you. Again, me, I sort of hate it when SolidWorks like automatically snaps to the in context part because I didn't want it to most of the time. But we're getting a little nuts here. Getting a little nuts with this design, right? So I'm just going to keep rolling through and doing the same thing to just about every one of these. 0, 40 thousandths, 40 thousandths. And that should be more than enough clearance. Right? The plastic is already bigger, way bigger than the pins. The plastic, again, looking at the physical board here in my hand, the plastic is way bigger than any solder blob is going to be. And then 40 thousandths per side, so 80 total. That should be plenty to make sure we don't hit anybody. So here and here, and then midpoint that guy, and vertical that guy. I'm still, you see my cursor bouncing all around this because I'm still trying to get used to, where all the icons are. Hey, I don't want to risk. I don't want to risk it. It looked like it wanted to jump to the midpoint. I don't know if that's printing or if that's plastic, so I'm not going to risk it. Let's not get too insane. Actually, I already did the vertical one, so I guess that whole insanity is my fault. Where's the center? Right there's the center. Select the line and center and horizontal U. And this is the fun part. However, I mean, doing it this way, now these guys, those I really wish, whoa, that guy's plugged in and turned on. That's not good. These guys, I really, really, really wish I had unscrewed this board or had brought one of the other ones. So I do believe those pins are in a weird spot. No, they're still, I mean, according to the physical board, they're still well within the screen print outline. So as long as our cutout is outside that outline, we're going to be clear all day. So, I mean, I can do the same exact thing with all of these guys. Boom. Boom. And boom. And I think I'm going to stick with the 40 thousandths theme. Again, looking at this, this looks fairly accurate to the physical one I have in my hand. So the screen printing puts the pins, toward that side of the screen printing. And that's definitely where the solder pads are, and they are well within. So yeah, if we go, stick with the same plan. And again, I'm going to go 40 thou from the plastic, not from the printing, just because I want to. I mean, nobody told me I couldn't. So 3.04, and centering is going to be tough because that's not one line, but that is. So why can't I center it to that? Where are you? Grab that center and grab that line instead of the plastic. We can cheat it a little. Why not? Midpoint, vertical. Now, don't waste your time. Already did the vertical one. Grab the midpoint. Where are you? Midpoint. And here, and that should be one line, is it? Yes, good. Midpoint that guy. I'd like to work from the, I mean, just for sanity's sake, I'm going to work from the plastic, overbold wherever I can. So do it again. and grab that guy, midpoint U, vertical U, grab U. I'm getting better. I'm getting better at remembering what my icons look like. Every once in a while, you still see me reach for a midpoint when I want a coincident or something like that, but it's getting better. So, again, 20 years worth of habit is hard to break sometimes. So, off of plastic. Dimension off of plastic. Always off of plastic. 0, 4. 0, 4. 4. Good, good. Everybody's locked down. Black. I like it. I don't like unconstrained sketches. If you've seen any of my other SolidWorks videos, I highly recommend it, one, because those are a slightly different tone in that the idea was more lecture, I guess. But you'll know I hate unconstrained sketches unless you have a really good reason. I mean, lock your sketches down. You don't need stuff moving around on accident when you don't intend it to move around. So it doesn't take very long. I mean, it is extra work. I mean, I could leave all of these, like, this is guesswork, right? I made up 40 thousandths. I completely made it up. I made up the fact that I wanted to go from the plastic instead of from the screen print, right? I made it all up. I could literally leave this blue just like it is, and it's going to clear the solder all day. It's going to do its job. I just like my sketches locked down, so I'm going to lock my sketches down. It's just the way I do it. So here we go. There's no real speedy way to do this kind of thing. It's just repetitive and over and over, and I mean, we are getting there, but so grab the center line, and you have to go to that point there, and you're coincident, not a midpoint. Vertical, and grab another line, and center where you. You know what I probably should do, and in fact I'm going to after I finish this one, is rather than do like 30 of these things and then see if my whole connect the dot plan will work, I should probably try a couple of them and see if my whole connect the dot plan will work. Yeah, why don't I do that? So I'm going to finish this one just because it's already started. I don't want to forget where I am. Horizontal and 40 thou clearance everywhere. 0.04 and 0.04. When making things up on the fly, nothing sounds more official than having a plan. So that and construction, everybody. All right, now the question is, what do I want to cut out with? I mean, should we go completely nuts? Grab the spline. Ooh, Beziers. Nah, let's go with the spline. Let's try it. If I grab there and there and just start outlining, the hard part's going to be, keeping track of what I want to cut. Ooh, no, I don't like that. That's going to, yeah, I don't like that. That's going to dip in way too close for comfort to where we wanted clearance. So let's get rid of the spline. I mean, really, you can just use a line and just start drawing, I guess. And we do have the ability, like, it doesn't have to be one interconnected shape, right? We can do a cut. I mean, we could do it a couple of ways, really. We could do one interconnected shape. That's always the option. Like, cut out one time, be done. I could leave all of these, like you mentioned in the comments, I could make all of these construction lines, the midpoint lines here, make those construction, leave the rectangles intact. In fact, that might be the way to go. just cut out the rectangles. I mean, that at the end of the day, that's going to give us the most support, right? If we just cut out exactly where we need and don't mess around with any fanciness. I like that. Change of plans on the fly. I like that. You're right. I'm going to make all the midpoint lines construction, and I think leave all of those. So we'll Control Z do it? Or is that just going to... There we go. So I do have to go back and make all of those other lines construction, which I will do in just a second. But for now, I'm going to unconstruction these guys. And then grab. Yeah, that'll do it. Rather than... I was going to get too fancy. Ultimately, I mean, frankly, in the back of my head, again, since part of my reason for doing this stream is to go through my sort of thought process as I work through this stuff. In the back of my head, I was thinking I was too lazy and I didn't want to go through all the effort to figure out how to outline one cut. So, I mean, occasionally in engineering, well, actually, I was going to say occasionally in engineering, laziness wins. I was told once, actually more than once, that I mean, the best engineers, some of the best solutions come from being lazy, right? We want to make things easier. That's where new ideas come from. Trying to make life easier for ourselves. So a long tradition of engineering laziness has led me to this point. We're just going to cut out individual rectangles and call it a day. This one's going to be weird. This one's going to be weird. So I have yet to decide. That is an infrared sensor. So on here, and I promise I'm going to go full screen, and I promise to remember to go back to the CAD. So on here, that's the infrared sensor. That allows these things to basically interpret. I mean, it's all up to coding, right? What program you put in it, but it allows them to interpret the why am I blanking? The signal from a TV remote, just a standard television remote. In fact, the ones I take to the career fairs and stuff were just some cheapies I bought at Walmart. And that's what that does. This is the IR sensor, and according to the board, it is soldered to the board. I did that so that in the schematic in KiCad, it would show that as a component, the infrared sensor, because all of these, like this HCSR SR04, SR0404, that's these ultrasonic sensors. I did not put these into KiCad because it can't treat this as one component, at least not easily. So for all of those, I just used the pin headers, and that's why they came in as pin headers. For the IR sensor, the infrared sensor, it's one of the only components in this entire robot that is a standalone component, right? The thing that the SR04 ultrasonic sensor is a whole collection of different ICs, and there's a speaker and a microphone, all that good stuff. It was just easier just to put the headers in here and call it a day, right? I don't have to reinvent the schematic for a product that I'm just going to buy, right? I'm buying this. I don't need a schematic for it. But this, since it was one component and I am buying this one component, I decided to do that. In actual practice, though, these holes are still 0.1 apart, 0.1 inches apart. And where's the webcam? There we go. And I still used a header and just sort of plugged the IR sensor into the header. So that's going to be, all of that to say, that's going to be the tricky part here is, I mean, realistically, I have no idea where the 40 thousandths clearance should be. So honestly, this one, I may just leave blue. Leave it unconstrained. That is a thing that I hate. I don't like to do that if I can help it. But I think I'm gonna have to for this one. But I want to get off rectangle. What I can do is I know if I'm, well, regardless, if I'm putting the actual IR sensor or a header there, I can select these and I can set these equal. So I at least know that. Equal. I at least know that. Length I don't want to set equal because this has only got 3 pins. This guy has got 4, but I could jump ahead to this guy. right? And set up this guy the same way I did the rest of my rectangles, because this has got 3. Now this one I also cheated on. So let's vertical that. I also cheated on this guy because this is a switch that's soldered directly into the board. It is not a header, and I just used a header there because the spacing was right. They didn't have, KiCad's library didn't have a switch that worked for me. So I decided just to grab a part that had the spacing and figure it out later. You know, fair play, right? 40 thousandths. 40 thousandths. So that sized now, I'm going to say appropriately, even though since I made up dimension, all these dimensions are effectively made up, I don't know what appropriate is. It's sized appropriately for a 3-position pin head, which means if I set this now equal, so it is now length and width equal to a 3-pin header, and I can see where the holes are. I can sort of guess and just, I guess I could, do I wanna, I mean, I guess I could. I can. The size is there, right? I don't need the 40 thousandths anymore. I don't need the length, but I could drop lines in here. I suppose via a proper designer and get this in the right spot. Except, oh, there we go. I can see that. Concentric. Yes. So now that's centered in the hole. Now if I make this vertical, pops my width in, and do the same thing for one of the side holes, and that'll lock in the vertical position. And here, and concentric. Where are you? Concentric. And horizontal. Go back to a straight top view so we're not looking funny. There we go. We should be perfectly centered around those 3 holes, which, regardless if in the final product I decide to solder the IR sensor directly to the PCB or put a header there, now it's not going to matter. It's sized for either. Well, I mean, it's sized for either anyway, because it's really more dependent on where these holes are than it is where this plastic is. So, yeah, awesome. Cool. I don't have to leave blue in my sketch after. I hate blue in my sketches. I don't have to do that after all. So, now, the tricky guy, this fuse is a little tricky because the solder pad's hanging out here, and I have no idea how big that solder pad actually is. And I have tried, as far as I know, again, not an electrical engineer, I have tried in KiCad to measure the solder pad, and I honestly have no idea how to do that. I can measure the diameter of the hole. I can't figure out how to, it shows the solder pad, I can't figure out how to get a dimension off it. So I'm going to straight up guess as to where this one should end up. And maybe this one I do leave, underdefined. So I do know that if I am at the silk screen, that is plenty of clearance. These whole, the solder pad, looking at this PCB, the actual physical one in front of me, that solder pad does not touch this screen printing, the white lines. So as long as I'm at the white lines, I'm wide enough. I'm definitely wide enough. The height is going to be the thing, and I mean, it's just going to be a guess, really, because I don't see. I could be a nerd and get a ruler out. That's the other thing I always keep handy, except now I don't see it. I've usually got a machinist scale sitting out here when I do this kind of stuff, just for quick and dirty. When you're reverse engineering something, it's a good idea to be able to take measurements off the thing you're reverse engineering, but we'll just do it that way. We'll do this. And like I said, in this case, I'm going to just make these coincident. Because if I'm at that screen printing, I am well clear of these solder pads. I mean, like all day long with plenty of clearance. There's at least as much clearance, probably more than my 40 thousandths that I put in down here. There's more clearance around these solder pads. Vertically could be an issue. Let's center this thing first vertically. So here, right, midpoint, random line to midpoint and horizontal. That will at least lock us. Make sure, did I do that for the earlier ones? Nope. Boom, boom, you need to be construction. Don't want to forget that. It's like you said in the comments, that's exactly right. It will screw up when I go to make a cut if I leave some of those not construction. And this is, I don't like making it a wild guess, so bear with me as I dig through my desk drawer here, and there should be a machinist scale. Where is my machinist scale? I don't see my machinist scale, so I'm going to do it super scientific. See if this cheap ruler somebody gave me once has enough resolution on it to see how tall that's going to be. What are we in, 16? 16ths of an inch. So the top solder pad is exactly, or I should say not the top. The top of this solder pad is almost exactly a 16th of an inch above this screen printed line. That's almost perfect. So 16th off the top of my head, is that the 1875? Tell me it is, and I'm just an idiot. The 1875, nope. So that's 0625, 62 thousandths, 63 thousandths. Make it 100? Another 40 thousandths just to make sure we are clear. Sounds good to me. I mean, we've been using 40 thousandths everywhere else. So make it 100. Make sure we're clear. I mean, that probably ought to work. And the great part is, I mean, if it doesn't work, we'll always think it should have. Yeah, why not? Sounds good to me. So, all right. Grab this one. And I think we're getting there. So grab this one, keep going. Lines, center points. This is kind of where I think the next time I do this stream, and I'm hoping, at least until this particular project is done, like I said, I hope somebody finds this useful, but I'm planning on keeping this going because I'm definitely not going to finish this design tonight. So we'll shoot for the same time and place, day, whatever have you, next week, for whatever, to pick up wherever I leave off. But normally I would be, rocking out. I'd have some music running through my headphones here, but I definitely don't want to copyright. I mean, this video is not monetized anyway. There's no plans to monetize it. It's educational strictly. Besides, since the YouTube channel itself is through Baker College, I'm not exactly sure what the legal ramifications of that would be, but definitely don't want any copyright strikes. And my first stream ever, I do have the streaming software set up to sort of hide my headphone audio from the stream, so I probably could pipe myself in some music, but it's kind of a weird thing to be here. It's a weird thing to be talking it through in general. It's definitely a weird thing to be talking it through without, distracting music. So maybe next time I'll have to look in to make that happen, or play with the streaming software a little more. And I'm just going through and I'm doing the exact same thing to all of these guys. Ooh. Yeah, I've heard that especially if those producers happen to be affiliated with a certain mouse, that's very dangerous waters when it comes to copyright. Maybe not so more since he's I haven't heard if there have been any, official legal challenges to the whole public domain thing yet. But I'm sure that's coming. I mean, when Winnie the Pooh entered the public domain, it took him 10 minutes to make a horror movie, and so I'm shocked nobody's pulled that with the mouse yet. Again, 40 thousandths. Why? Because that's what we did everywhere. I mean, when it's completely made up, you might as well stick with it, right? There's no logical reason I can explain to you I picked 40 thousandths. It just looked like it would work. Uh, we'll keep going. These are a lot of rectangles. Rectangles for days. We've got. I'm going here to this segment because this is centered in this plastic connector, and the screen print on this top side, because of this tab, which I'm not sure why it's there, that, centering it here would not be a good thing. I want it centered here. So that's why I'm doing it not to the screen print, but I'm doing it to the plastic on that side. Or on the top, and then on the side, I can go to the screen print because it's one continuous line. Grab it there, go there. Horizontal. And, oh, you deselected. So that's another thing that I've noticed I have to get used to coming from SolidWorks is, things deselecting before I'm actually done with them. Like in SolidWorks, I could do 3 or 4 things to that line before I deselect it. And here I've got it just deselects itself. So dimensions 40,000. I think that's not it. We've got what? The whole Arduino? No, just the whole brain of the outfit, right? What to do there? I think for the Arduino specifically, I'm going to get a little fancier, the rectangles. So before jumping into the Arduino, I'm going to leave that for the last. I'm going to drop the angled rectangles that we need in these two. So first, before I try to send, well, I can't. Ooh, that's interesting. I can't. Oh, I know what I can do. I was going to say I can't vertical these in order to center these rectangles, but I can do is use a tricky combination of parallel and perpendicular constraints. So that's what I'm going to do. So let's dimension first and make sure that's at 45 degrees. Dimensions, I'm getting lost. It's also getting late. That must be a sign. So 45 degrees. Why? Because I designed the PCB. I know I put these at 45 degrees. Yeah, I mean, they just are. So there's that. We're going to use the same basic technique. Grab that. I'm going to midpoint this, but again, I can't just vertical it, obviously, because we're at an angle. So midpoint, but what I can do is I can make it parallel with that. Parallel. Now we're centered. And I can do the same thing on this. Midpoint here. Where are you? Light up. There we go. I do kind of like how SolidWorks, I mean, this isn't bad. SolidWorks gives you, let's call it earlier warning when you're getting close to the midpoint. Like this, the Onshape, you got to be right on it, man. It's, undo. I hit coincident. See? Forgetting what my icons look like. Oh, I don't want midpoint. I do want, did I just select the wrong point? Is that all I did? Coincident. There we go. I must have selected this point or something. So deselect and parallel. I can either parallel with the bottom here or perpendicular to one of these. I'm just going to parallel it. Why? I mean, no reason. Just because I can. I use parallel on the other one. Might as well use parallel on this one. I can or should. Anyway, I don't know that I've tried this yet. Should be able to put the same 40,000ths. And it should, red. Why don't we like red? What don't we like? Yeah, we're in context. I get that because why don't we like a dimension there? Delete. What don't we like about a dimension there? You're parallel. Is it because this is defined? Let's get rid of that. I'm now curious why that's, let's make this parallel instead of defining an angle and see if it will let me dimension it. I mean, what's weird is it let me dimension it and then it's still 40,000ths, but it freaked out. Now, I'm not going to blame Onshape for that because SolidWorks do the same thing sometimes, right? You be cruising along and doing everything the same way you have, and then all of a sudden the whole thing goes kaboom, and you're wondering why. And I mean, just because it felt like it, right? So yeah, parallel, I guess, instead of 45 degrees, and I bet. Well, it's definitely going to break if I throw an angle in here now, because that parallel will have it over constrained. But yeah, if I drop it in, it's 45 degrees anyway. So I don't know. I mean, it's in, it works. I'm not going to question it too hard. Line here, midpoint me. Ooh, I almost dropped that in vertical. That would have been an interesting, one of those interesting things to figure out why things broke later. I did construction those? Yes. That is construction. Make sure I don't forget any of those, little detail. No vertical. Don't go vertical. Vertical will break. Coincident there. Okay, you and you are parallel. You and you are parallel. 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 Okay, and you are now parallel. Cool. Now watch it break. I've also had SolidWorks do this to me before, where you'll do something the same way twice. The second one will break, and you'll have to go back the original way. So that would be absolutely hilarious if this inherited it as well. So there we go. And I think, all right, that's everybody outside of the Arduino, right? Kind of looks like it. I'm just going to double check quick and make sure that all of those little centered lines are all construction, so I don't run into any headaches later. We're good. We're good. We're good. We're good, and we're good. Okay. Now for this guy, I think I'm just going to get a little fancier, not much, a little fancier, and just make a continuous sort of U-shaped cutout for this guy. Because I definitely, I mean, of all the stuff that plugs in here, I want the Arduino to have the most support. I don't want to just cut, I don't want to cut a big rectangle and leave this whole middle unsupported. Because this thing has got so many pins, it is so hard to seat on all of those pins. You've got to push pretty hard. And just the nature of, again, I mentioned it like an hour ago, tolerance stack up is a thing, and if every pin is off by just a little bit, it doesn't take much to make things harder to push together. So I want backup here to definitely make sure when we seat the Arduino, we're not just pushing against the board. So I'm going to go ahead and do this with lines and just draw a U-shape around this whole mess, and I'll go in and lock it down with the 40 thousandths dimensions and center some things here in a minute, but first the U-shape. This corner isn't going to be too terrible, so I'll let that go all the way down here. Come over here and shoot back up, and that's probably not vertical. So first thing I want to do is make sure that that is vertical. There we go. I still don't understand why. I'm not used to, I mean, SolidWorks will move things. But on that very first thing you do, whether that's a dimension, whether it's a vertical like I just did, whether it's, any of that kind of stuff, the first thing you do to lock down a sketch entity doesn't move that much stuff. I don't understand why this does. It is a little annoying. It is a little frustrating. At the same time, it is what it is, right? I mean, at a certain point, you can keep complaining. And I mean, it's YouTube, right? I'm going to keep complaining. It's, sort of the nature of YouTube. But again, I bet everything moved, right? It looks like everything shifted when that thing shifted over, which I don't get it. I mean, I don't think all of that stuff should move. Like the things that are connected to this top line that I'm working with, sure. Like these two vertical lines, absolutely. There's no reason that I can see that this stuff over here should move. It should, but it does. And we can either complain or realize that I chose to use this, and we take the good with the bad. And so far, I mean, realistically, honestly, I've only got a couple of hours experience with Onshape, and honestly, I'm pleasantly surprised. Maybe that's even, a little more derogatory than it should be. I mean, there's nothing major I can complain about. Everything I would complain about is relatively minor. I mean, at the end of the day, I'm on an educational account here. I did that because I wanted to play. They've got some options for setting up assignments and stuff, and I wanted to play with some of that. But realistically, I mean, it's free, right? It's free, full functional CAD. So far, it's been able to do everything I've thrown at it that I would expect SolidWorks to do. It did back in the little first look video that I did. I mentioned and actually showed in the video that I was getting some slowdowns. And I do need to apologize to the Onshape people because it turns out that the slowdowns were my fault. I use Overleaf a lot for writing, and hardware acceleration was giving me issues. It was browser hardware acceleration was causing my Overleaf cursor to just plain disappear on me. That's centered. Oh, because I defined it down here. I don't need a center because I defined the dimension on both sides. But hardware acceleration was causing my cursor in Overleaf to disappear, which is, when you're in a text editor, it's kind of important to know where your cursor's at. So it turns out that when I did that Onshape video, I still had hardware acceleration turned off, and that was all of my slowdown. Like I haven't seen, I mean, I'm on my desktop at home right now. On my work laptop, it slows down a little, but that laptop just has integrated graphics. This desktop is not super high-end, but it definitely has better than Intel integrated graphics. And I haven't noticed any lag at all since I, remembered that I had hardware acceleration and turned it back on. So we now have everybody outlined. Yes, yes. Looks like it. I did double check that everything was construction. I can accept the sketch now. All of that for one sketch. Isn't that fun? All right, and we do have in context a lot of it because I dimensioned to various things, right? See how the pink, that's kind of cool, shows you what the context is. Let's extrude and remove. Now it wants to punch all the way through. We don't want that. I wrote it down. And like I said at the beginning, this is literally just scratches for memory. I'll switch back to big. Like, you would not ever be able to, oh boy, there we go, little shadow. You would not ever be able to take my notes while I'm doing this and recreate anything. Like, it is, when I'm done with these design sessions, whatever piece of paper I was working on is literally thrown away because the notes are meaningless once you get, I mean, it's mostly meaningless to me right now. I'm thinking the 100 thou on here was how deep I needed to make this, I hope. So let's try it. 100 thou, are we within? Yep, we're within the plastic. Sure, why not? Okay. I'm going to accept that. I'm going to close this. All right, that gets rid of the PCB, and I'm going to go to my main assembly. I want to change transparency here for a minute. Now, one thing I have not yet figured out, I played with transparency a little bit, not yet figured out how to make it stick. Like in SolidWorks, if I want to make this transparent, I do that, and it'll stay that way until I tell it not to be. Here, doing it this way, and maybe I did it wrong, but as soon as I close this, it goes back to opaque. But if I make it transparent and look and just, eyeball it, we should have plenty of clearance everywhere, and it looks like we do. And honestly, in fact, it looks like we can make this piece of plastic even thinner. Do we want to do that? Do we want to do that? How much material do we have? I'm kind of in the head zone where I want this thing in the end. I mean, I expect it to look funky. Like, I'm not going to get to it tonight. In fact, I plan on wrapping somewhere in the next 5 or 10 minutes. So I'm not going to get there tonight. But in my head, I anticipate this thing when it's done looking really funky. Like, if you gave it to a guy with a CNC mill, he would look at it and, kick you out of the place. Kind of funky. That said, for now, how much, where's my parallel? 140. Wasn't I shooting for 100 or an eighth? I mean, 140, 15 thousandths off of that gets us to an eighth of an inch. I'm going to leave that alone. I'm going to leave that alone because at the end of the day, this thing is going to be 3D printed. Now, one thing I don't know is because I don't know what the full thing looks like yet. So I don't know which direction it's going to be 3D printed. So if I assume, and I don't know that this is correct, but if I assume this is the print bed, 140 thousandths at 20, that is really thick. At a 0.2 millimeter layer height. Is that right? 0.2 millimeter. I know I have to remember how that printer runs. Is that right? 0.2, I think, is the coarse setting. You know, the speed setting. You get thinner for higher quality settings. Does that sound right? I think that sounds right. Because I remember, is it 15 thousandths that we used to set? I'm trying to remember. I have settings. I don't think I have any of the parts on this computer. I have settings that are designed specifically to print 0.2 millimeters. Yeah, that's what I'm thinking. But I have prints that are specifically designed to print just enough layers to not infill, which is 3 layers, and I want to say that was 45 thousandths of an inch, which is, again, back to the calculator, because, I never converted a metric in my head. Well, it must not be 45, because that's only 11. But yeah, I think you're right. I think 0.2 millimeters. I think 0.2 is what? 0.2 times. It needs to be divided. Get your math straight. Get your conversion straight, dude. 8 thousandths, 16, 24. That sounds about right. 30, maybe it's 30 thousandths I used for thickness. So that's where my head's at. Do I want 140? Because 140, now again, I don't know what way this is going to end up being printed, because with all the stuff that has to get added to this thing yet, I mean, this direction might suck. Setting this as the print bed might be stupid. Like, I don't know yet. It might have to print with this on the bottom or this on the bottom. I don't know. But what I'm thinking is, if this is the bottom, do I really need infill or enough material to infill down here? Like, it could just be, my default is 3 layers, right? That much I remember. I set that at the lab. I set it here at home. 3 layers before it starts to infill. And that should be the 0.2 millimeters. 30 thousandths? It's roughly 8 thousandths times 3. 30 thousandths of an inch, I think, is what I usually use as the guideline. It's really 24. 30 thou, though, usually the slicer, fudges that fudges it correctly. So I think 30 thou is what I usually use. The question that I'm struggling with in my head right now, again, since the whole purpose of this is to talk through this stuff, do I want the bottom of this that thin? What is the bottom of that actually doing? The bottom of that is doing nothing. Like, I mean, except for this, like the bottom of this big Arduino U shape is kind of important, because you go pushing on this guy without any bottom there, it's going to just pull right out. But the rest of it, I mean, the backup that we're looking for to make sure we're not, I mean, these could really be through for all I care, right? Like, this thing could be way shorter, as long as I got enough plastic to make sure I'm not dragging those pins on stuff. And the bottom then is only really there for aesthetics, so that, like, if you look at the bottom, you won't be able to see anything. It'll be clean. Let's do it. Let's make that 40 thou. What was it now? It was 140? So to get to 40 thou from here, So parallel distance, 140 down at the bottom right there. It's 140. If I want 30, all I need to do is take, 110 off of the total extrusion, which is this guy, this feature. So if I edit that feature, I want to take 110 off that, and just for sanity, I'm going to do it in the calculator. I believe that's 190, but minus 110. That is 190, so 0.19. Now watch me screw up the math somewhere else and it gets way too shallow. So now we're a lot thinner. Got my 30 thou. Like I said, if I slice it, I don't have... So the lab printers are Anycubic, and they require at least as far as I know, they require Anycubic slicer. Here I've got Cura because this is an Ender. And the settings are definitely different. I did set the layer heights to be the same, but I'm going to leave it here for now. Maybe I'll export it later or take it to the school and see what those settings are, or see how the slicer interprets it. But again, I mean, I could be arguing about nothing because it could end up being printed on this face or something, right? So I'll leave it there for now. That's not a big deal. If we need to add material, we need to add material. So that, I think I'm going to end the stream here. That was less progress than I kind of expected, but like I said, hopefully that was useful to somebody. But the idea was to sort of talk through, some of the thought process. And when we get to, some of the more in-depth stuff, like the next time, and we'll do this again and again, same time next week, we'll get to the motor mounts and the battery case and stuff like that. And I think the idea that I have for this will become more clear. Now, whether it'll work or not, that's an entirely different question. But at least as far as viewers are concerned, the idea that I have in my head for what this could look like will become clear, and sort of, what I've been saying, the difference between starting like the original version of this that I tried last week, not on stream, but the original version looked a lot like this, and it basically started as a big block that I started to carve stuff out of. In this one, what I want to try is to start with basically nothing and add to it, sort of a different, coming at the design from backwards. So we're going to do it that way. Like I said, I'm going to end the stream there. Thanks for showing up. Like I said, next week, same time, so Tuesday, 8 o'clock, and we'll pick up right here. I promise not to touch the thing in the meantime. It was really hard. Waiting for the stream, because the other unstated reason that I did this is, I'm an engineer at heart, and as a teacher nowadays, I don't get to do a lot of actual engineering, so, I got to have some fun once in a while, too. So, awesome. Again, thanks for being here. I'm going to call it there. Have a great night, and we'll see you next time.